Good evening, everybody. Welcome to week 1, lecture 5, the theory of optimization. In this lecture, I'm going to walk you through optimization, the theory of optimization. We're going to look at the conditions for profit maximization as well as cost minimization. And then later, we are going to look at the concept of relative maxima as well as relative minima. The idea here is for us to be able to determine the profit maximizing level of output for both the monopolist as well as the perfectly competitive firm. So the primary goal of optimization is to make the best choice, to make the best decisions. There are so many alternatives. So our goal here is to make the best decision. In fact, this is the study of economics. It is the study of constrained choice. So all what we are going to be doing in microeconomics for this semester hinges directly on optimization. So when we look at the theory of the consumer, we're going to look at utility maximization. How the consumer tries to maximize his happiness or welfare, subject to his limited income or limited budgets. We are also going to look at the theory of the farm, how the farm tries to maximize its outputs, subject to his limited inputs. So these are some of the things that we are going to look at today. And then hopefully, I will walk you through integral calculus briefly, and then that will be the end for our math review. So our math review will end today, and after today, there will be no more math review. So all what we're going to be doing now is pure economics. So I want you guys to pay attention to this one because you're going to be, you need to listen to this video in order to do the second quiz. You need to go through lecture 5, 6, and 7 in order to do the quiz. So I want you guys to listen attentively. So let's go ahead and get started. So as I said earlier, the major goal of optimization is to obtain the best alternative from a given set of alternatives. So considering any possible restrictions on the choices. So here, we are talking about restrictions on the choices here. So this brings us to the idea of constraint optimization. So for constraint optimization, there are certain restrictions that are placed on the decision maker while he's trying to make his choices. So for unconstrained optimization, there are no restrictions on the decision maker's choices. So we're going to deal with those two aspects of optimization today. And hopefully we'll wrap up this math review this week. So unconstrained optimization is used when a decision maker wants to make the best choice from a set of alternatives with no restrictions on the choices. So here, there are no restrictions placed on the choices that the economic agent is planning to make. Now, for example, we have a perfectly competitive farm trying to maximize profits. So in an unconstrained optimization problem, we consider a farm seeking to maximize profits, which are defined as the difference between just revenue and cost. So here, we don't have anything like uh, the constraint equation. We only have one equation here. So that is what makes this one so easy, so different from constraint optimization. For constraint optimization, you have to deal with a constraint in the optimization problem. So for this unconstrained optimization, it's only one equation that you need to deal with. If you are to maximize, let's say, profits, so you only deal with that equation, which is the objective function. So this is the difference here. For unconstrained optimization, we only concentrate on the objective function, which is what? To maximize profits. Or what? To minimize cost. Or to minimize electricity usage. Those sort of things. So we are not going to deal with any restriction here. So that makes this particular topic so easy to handle. Now, when we have restrictions, then the optimization problem becomes more complex. Because here, we're going to deal with the objective function, and then we're also going to deal with the constraint facing the decision maker. So, but for unconstrained optimization, we are only going to look at the objective function. That is the objective of the economic agent, the objective of the decision maker. So in this particular case, the farm is the decision maker, is trying to maximize profits. That is trying to make the maximum profits from the production of the goods or from the sale of his product. He's trying to make the most from the sale of his products. So we have the function here, maximize Q by Q. Now remember, we say maximize Q here because this represents the choice variable, the output. The farm is going to choose this one in order to maximize its profits. Now let's look at this example here. Now I said in order to get the total profits, we need to multiply, first of all, need to obtain the revenue, and then next we subtract the cost from the revenue to get the profit, right? So, but in unconstrained optimization, the idea here is to obtain the inverse demand function. If we are given a demand function, so all we need to do here is to obtain the inverse demand function. Why do we obtain the inverse demand function? The reason is that a farm wishing to maximize profits always wants to sell its product at the maximum price. So because the farm wants to sell its product at the maximum price in order to maximize profits, we need to find that particular price. And the only way we're going to find that price is to obtain the inverse demand function from the direct demand function. So as you can see here, as you can see in this case, we have an inverse demand function here, which is d to the minus 1. So we have our direct demand function, which expresses the quantity as a function of the price, which is dP. dP is the direct demand function. But when we are trying to obtain the profit maximizing level of output, so what we need to do is to first of all derive the inverse demand function. The reason why we are deriving the inverse demand function is because we want to find the maximum price at which the farm is going to sell its product. And the only way to obtain the maximum price at which the farm is going to sell its product is to obtain that inverse demand function, which expresses the price as a function of the quantity. So that is the first step. I need you guys to note this one, because you know the revenue is obtained by multiplying what? The price by the quantity. The price by the quantity. And if you are given the demand function, the direct demand function, which expresses the demand as a function of the price, when we say the direct demand function, you have QD, let's say equals 10 minus 2 PD, right? So this is the direct demand function. Now, if you want to find the inverse demand function here, that is to say, you want to find the maximum price at which the farm is going to sell its product. Our aim here is what? To maximize profits, right? The farm wants to maximize profits. He can only maximize profits if he is able to sell his product at the maximum price. And for us to find that maximum price, we need to obtain the inverse demand function. I guess you get the point I'm making here. So if we have QD equals 10 minus 2 PD here, so we want to find the inverse demand function, which is the price as a function of the quantity. So what we do here is to make price the dependent variable and then quantity the dependent variable. How do we go about doing that? It is so simple. Take the minus 2 PD to the other end of the equation. Remember, when you move a term from one equation, now you have an equation, right? You have the right side and then the left side. If you are moving a term from one side to the other side, the sign in front of that term always changes. The sign always changes. You need to know that. Now, we want to move this minus 2 PD to the right, to the left-hand side. So what do we do here? It becomes 2 PD, and then this equals to what? 10. And then we want to do the same thing to the QD. We want to take it to the left, to the right-hand side. Now it is QD. Instead of QD, we're going to have minus QD. Okay? You got it? So now the QD goes to the right-hand side, and then it changes to minus QD. The minus 2 PD goes to the left-hand side, and then changes to 2 PD. Please, please do not leave this negative sign unchanged. Please Do not leave it unchanged. Do not say minus 2 PD equals to 10 plus QD. No, that is wrong. It should be what? 2 PD equals 10 minus QD, okay? So once you have that, now we want to find the value of PD. All we need to do is to divide by the coefficient of PD. Basic math. Divide by 2, which is the coefficient. That one cancels. And then whatever is done on one side of the equation must be done on the other side of the equation. So if you add 2 here to the right, you need to add 2 to the other side. Okay? If you add 2 to the left, you have to add 2 to the right. If you subtract 1 from the right, you have to subtract 1 from the left, so that the equation will be balanced. So 10 over 2 here, and then you have QD over 2. So 10 over 2 becomes what? 5. And then QD over 2 becomes what? 0.5. Because 1 over 2 is just 0.5, right? 0.5 QD, sorry. QD. And then this is what? Your PD. So now you see, this PD becomes the maximum price that the farm is going to charge or is going to sell its product. Now, we are now free to multiply this price by this quantity to get our revenue. So that's all we do. We say 5 minus 0.5 Q multiply by Q, and that gives us the revenue. So then, if we want to find the profit now, what we do is to just get the difference between the revenue and the cost, RQ minus CQ. So the profit pi Q equals to what? RQ minus CQ, which is revenue minus cost. So once we have that, what do we do next? Now we take the first derivative here, the first order derivative, the pi Q, the Q, and then equals the RQ, the Q, minus the CQ, the Q, right? Now, if you go to Landsberg appendix, appendix A is the same as annex A. Go there and look at those calculus review. Go through your appendix A. You need to go through that, and hopefully you'll be able to catch this one. So remember, pi Q here is just the derivative of the profit function with respect to outputs. And when we say pi Q is what? It is just the pi dq. That is pi Q. Pi prime Q, sorry. Pi prime Q. Now remember, the term is what? Pi prime Q. So this is the same as what? As the pi Q dq. Okay? And then when you see R prime Q, it's the same as what? The RQ dq. This is just a change of notation, right? So don't get mixed up here. So the CQ dq is just the same as C prime Q, right? It is just change of notation. So the condition for profit maximization is that what? Pi prime Q equals to 0. So you need to set that one because that's the first order condition. It is a necessary condition for profit maximization. Do you know why they set the price, the derivative of pi profit to 0? Because that is the only condition that will equate the marginal revenue and the marginal cost. So if you have pi Q equals to 0, then automatically marginal revenue will be equals to marginal cost, because the marginal revenue is the derivative of the revenue function with respect to quantity. That is the addition to total revenue as one more unit of output is produced or is sold. The addition to revenue as the farm sells one more unit of output. So that is the marginal revenue. And then the marginal cost is also the derivative of the cost function with respect to the output, which is also the addition to total cost as the farm produces one more unit of output. So that is the marginal cost. So it is the extra cost incurred by the farm when it decides to increase production by one more unit. So that is the marginal cost here. And it is the derivative of the total cost function. In other words, you can also represent the marginal cost as the change in the total cost over the change in outputs. Okay? So that is the marginal cost. So the reason why this first order condition needs to be set to 0, the derivative of the profit to 0, is because that will equate the marginal revenue to the marginal cost. And that is the profit maximizing level, the profit maximizing condition of the farm. Okay? Now let's look at one exercise. Now this question is from Appendix A. Appendix A, Price Theory and Application, page 628. So here, the question says a farm faces the demand function Q equals to 100 minus 2P. And the total cost function CQ equals to Q squared. Determine the profit maximizing level of output of the farm and the corresponding price of the product it sells. So, heads up, guys. In the exams, the questions are going to be, the questions will be like this. They are similar to this one. These are the type of questions that will be set in the exams, in the finals, the midterm. So I want you guys to listen attentively. These are very easy questions to solve, and most of your exams, you're not going to be seeing a lot of calculus there or complex calculus. It's just basic stuff like this. So you need to, these ones, I believe you guys will be able to handle this one. Okay? So what we need to do here is first, we need to find the maximum price, right? Because the aim of this farm is to maximize profits. It can only maximize profit if it's able to sell its products at the maximum price. So, looking at the demand function here, where the quantity is expressed as a function of the price, can we just use that one directly and obtain the revenue? No. No. We don't need to use that one directly to find the revenue. That is by just saying price times Q, and then we have 100P times 2P. We don't do that. We don't do that. So what do we do here? We try to find the maximum price here. In other words, we are going to find the price. We are going to find an equation or a function that expresses price as a function of the quantity. So when we have that function, then we can then multiply that price by the quantity, because we have price as a function of the quantity, and then if we multiply that price by the quantity, then we're going to have revenue as a function of the quantity. So that is our plan. So here we already have the cost function, which is simple and straightforward. All you need to do now to find the profit function, in order for you to find the profit maximizing level of outputs, you first of all need to find the profit function. But before you find the profit function, you need to get the inverse demand function first. Now, here is a catch. If the demand function is given as what? Let's say P equals 10 minus Q, right? If it is given as P equals to 10 minus Q, so then that becomes an indirect demand function, right? So there is no need for you to do any transformation to that equation. So all you need to do now is to multiply that price by the quantity. You understand? So the only problem you have, if the quantity is expressed as a function of the price, so that means you need to convert this demand function to an indirect demand function or an inverse demand function. So once you have that, then you can multiply that by the quantity to get the revenue. So if you have the revenue and then the cost, just find the difference between the two, that gives you the profits. Okay? So once you have the profits, the next step is to find the profit maximizing level of output. How do we go about doing that? You need to find the derivative of that profit function with respect to Q. That is what? The pi a Q. And then you equate that to 0. You are equating it to 0 because marginal revenue must be equals to marginal cost for a firm to maximize its profit. So marginal revenue cost to marginal cost is the profit maximizing level condition of the firm. Is the profit maximization condition of the firm. So that is marginal revenue equals to marginal cost. So let's proceed. Now, the first step here, as I said earlier, was to find the inverse demand function. So how do we get that one? Again, we have Q equals to 100 minus 2Q. So all we need to do is to transpose, bring 2QP to the other side. Now, if you bring 2P there, maybe to the left-hand side, and then take the Q to the right-hand side, you're going to have minus Q, right? So now we want to find what is the price. We are going to divide both sides by what? The coefficient of the price, and that is 2, right? So you divide here by 2. You do the same thing to this by 2. You do the same thing to this by 2. And then what happens now? This cancel, right? So you're left with what? P equals to what? 50 minus what? Minus Q over 2 is the same thing as what? 0.5, right? Q. Right? So that is the price. That is the price. So we are now going to multiply that price by the quantity. Did you see what we did here? Price times quantity. P multiplied by Q. Already we know the price, which is this, right? We know the price, which is this one. 50 minus 0.5Q. All we need to do is to multiply by the quantity, right? All right. So if we do that, we have 50 minus 0.5 Q multiplied by Q. You have 50 multiplied by Q minus 0.5 multiplied by Q squared. Q times Q is Q squared. So you have to be very careful with these signs. Please, 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 please be careful with that, okay? Now, the third step will be what? To obtain the profit. How do you get the profits? It is just what? The difference between the revenue and the cost. That becomes RQ minus CQ, right? So what happens here? You have your pi Q equals to 50Q minus 0.5 Q squared minus your total cost, which is Q squared. But what is minus 0.5 Q squared minus Q squared? It is just minus 1.5 Q squared. Remember, when you say minus 1 plus 1, minus 1 minus 1 is minus 2, okay? You just add those two values and then you put a negative sign, right? If it is plus 5 is plus 10, right? So minus 0.5 Q squared minus Q squared. Please don't say it is 1 minus 0.5, which is 0.5. No, that is wrong. I see many of you made this mistake in your problem set 1. So you have to be very careful with the signs, okay? So once you have that, you have 50Q minus 1.5 Q squared, which is 5. So now we want to find the profits, maximize the level of output. So what do we do here? We differentiate the profit function with respect to quantity. Divide the Q, right? Originally we had 50Q, right? So, and Q is raised to the power 1. You have to multiply that power 1 by 50 and then take 1 from that exponent. 1 minus 1 is what? Is 0. So Q to the 0 is what? Is 1, right? So that's how we got that 50. And then we had 1 minus 1.5 Q squared, right? So you are going to take that to the power or the exponent 2 and then multiply by 1.5. So you have 3. So you have minus what? Minus 3Q. Remember, you are going to subtract 1 from the exponent at all times. That is the general rule. So it is minus 3Q. Also that. So once we have that, we have 50 minus 3Q equals to 0. And then we solve for Q. That one is very simple. Take minus 3Q to the other end of the equation, and that becomes a plus 3Q. And then you divide both sides by the coefficient of Q, and that gives you 50 over 3. So the answer is what? 16.67. Right? Now, if you look at Landsberg, they said 16 whole number 2 over 3, which is the same thing as 16.67, okay? So it is 16.62 over 3, which is the same, okay? Now, substitute for the profit maximizing level of output into the inverse demand function. So remember, we had the inverse demand function, which was given as what? 50 minus 0.5Q, right? Now, we now have Q star. Just take that and plug that value into that price. Price is what? P equals 50 minus 0.5Q. Now we are going to plug Q star into that. So it becomes P star equals to 50 minus 0.5Q star. But what is Q star? It is 16.67, right? You multiply by 0.5, and that gives you 8.335. 50 minus 8.335, and the answer is what? 41.2665. So the price, the corresponding price, the profit, the maximum price this firm is going to charge for each product is $41.67. So this firm is going to charge the $41.67 in order to maximize its profits. If it decides to charge a price below this one, it's not going to maximize its profit. So this is the idea. So the profit maximized, the level of output becomes 16.67. Good. Let's move on. Now let's move on to the concept of relative minima and relative maximum. Now, if you say a graph with a U shape, right? If it has a U shape, first the graph is what? Is decreasing, and then later it increases, right? So the point where the graph changes direction here, it changes direction from maybe increasing to decreasing, is what is referred to the relative minimum. So the relative minimum point here is that minimum point at the bottom of the graph, and the value of x at that particular point is referred to as what? The critical value. Now, how do you know that this function has a relative minimum or a relative minimum? It is easy to know. Just look at the quadratic equation, right? If the coefficient of that quadratic equation, let's say the x square, if the coefficient of x square is a negative, then you have a maximum. You understand? But if it's a positive, then obviously you have a minimum. That's how you know. It's simple, right? Now look at this graph. The function is what? Y equals to ax squared plus bx plus c, right? Now, what is the coefficient of x squared there? The coefficient of x squared is what? It's a, it's positive a, right? So automatically I know this has a minimum. Without even doing anything, I know it has a minimum because the coefficient of x squared is positive. So if I differentiate this function with respect to x, I'm going to have what? 2ax plus b, right? And then if I take the second derivative, because the second derivative is referred to as what? The sufficient condition for maximization or minimization, right? That is the sufficient condition. So these two conditions have to be met in order for what? Profit to be maximized or cost to be minimized. Okay? So we are still dealing with unconstrained optimization. We are only dealing with what? The objective function. There are no constraints here. Okay? So this function has a relative minimum. It has a relative minimum because the second order derivative here, you differentiate this first derivative, you get the second derivative, and that is 2a. And that 2a is what? Is positive. And if it is positive, it means this function has a minimum. Okay? Now the relative minimum there is given as what? Y star. Okay? Good. Now let's look at one typical example here. We have this as a function. Consider the following polynomial here. Y equals to x cubed minus 3x plus 5. Now looking at this function, they want you to determine whether this has a minimum. Obviously, the x to the power 3, right? It has a positive coefficient. Obviously, it's a minimum. Have you seen? That's how you know. This is not rocket science, you know. If that one had like a negative sign, then we think about it as having maximum. Okay. Now we are required to find the critical values here. So here it is very simple to do. You just find the y dx and then equate that to 0. If you do that, the y dx is 3x squared minus 3. Equate that to 0, that's the first order condition. Then if you solve, you're going to have what? 3x squared equals to 3. X is therefore what? Plus or minus 1, right? Once you have that, then the second order condition for relative maximum, minimum is what? D dx, dy dx, which is d square y dx square. And d square y dx square is what? It's just 6x, right? Because you have 3x squared, right? And then if you differentiate that for the second time, it's 3 times 2 is 6x. So that is the second order condition. Now, we want to see whether that has a minimum or a maximum. Do we need to plug in my negative sign there? No, because in economics, we don't deal with negative numbers. We deal with positive numbers. So as a result, n minus 1 is redundant. We just take 1 and then plug it into that 6x, multiply by 6. That gives us 6, and 6 is bigger than 0. So this particular function has a minimum, right? So the critical value, therefore, is what? Is x equals to 1. Now, question. What is the critical value? It is always the value of the independent variable for which the y dx equals to 0. Right? That is the critical value. In other words, they call that extreme values. Right? They call them extrema, extremum, or critical values, or optimal values. So I hope you get the point I'm making. Now, if we want to find the relative minimum here, we just plug in this critical value x equals to 1 into the original function y equals to x cubed minus 3x plus 5. If we do that, we're going to get what? 3. 1 minus 3 plus 5 equals to 3. And so the relative minima there is 3. Right? So now let's move on to relative maxima. What is that? Again, just like, we see a graph decreasing and then increasing afterwards. So when it changes direction, right, from that increasing to decreasing, then it becomes what? A relative maximum. So at the turning point, right, of a relative maximum, the graph is what? At a particular peak, right? So if we look at the graph here, this time it is not U-shaped. So it has a maximum point there. And how do you know it has a maximum point? Again, as I said earlier, look at the first term. It has a negative sign, right? That's how you know that this function has a maximum. Now, if you take the first derivative there, you're going to have minus 2ax plus b, right? Now, take that derivative again for the second time, d square y dx square. You're going to have negative 2a. And minus 2a is what? It's less than 0. And that function has what? A relative maximum. Okay? So that's how you know. So the x star there is the critical value. Remember, this is called the critical x value. That is the value of x for which dy dx equals to 0. Okay? Now let's look at the concept of relative minima here and the relative maximum, right? Now we apply them in economics, microeconomics, especially if we want to find the maximum profits, want to find the uh, optimal uh, level of input usage, want to find maybe the minimum cost, or let's say the minimum expenditure. So all those ones, we need to use this concept of relative maximum. Okay? There are top that. Right. So now if we have a cost function given as a C equals to F of Q. Now costs are minimized if both the first order condition and the second order condition they hold true. If both of them hold true, then costs are minimized. If any of this one is not satisfied, then costs are not minimized. The same applies to the profits. The first order condition for profit maximization is that the derivative of the profit function with respect to output must be equal to 0, and the second order derivative must be less than 0. If any of those conditions, any of them is not met, then profits are not maximized. Okay? So both the FOC and the SOC must be met in order for profit to be maximized, or in order for cost to be minimized, or in order for expenditure to be minimized. If any of those ones are not met, then cost is not minimized, expenditure is not minimized, and profits are not maximized. So, therefore, the profit maximizing condition therefore becomes the pi d q equals to 0, and then this square pi the q square is less than 0. Please make sure you know this one, because in the quiz you're going to be expecting things like this, simple things like this. So make sure you are able to do this one. So study them very well and then listen to the video. And make sure you study the whole of that's chapter 1, Landsberg. Then go ahead again and read um, microeconomics by Bruttigam. So you read that one by Bruttigam, and the one by Landsberg. Make sure you read those chapters for your quiz. Okay? Go over them. And remember, I posted the lecture 1, week 1, lecture 7, demand, supply. That one is straightforward. And I believe some of you have done Econ 101 or Econ 201. I believe that one is completely straightforward. But I will try to provide the video to that lecture so that people will be able to answer those questions in the test. Okay, so let's move on. Now we have this exercise here, and this is for you to practice. I need you to practice this one. I am not going to grade this one, but it is for you to practice. Please, when you go, make sure you are able to find the profit function for this. You are also able to determine the marginal cost. You know what the marginal cost is? It is just the CQ, the CQ, the Q, okay? When you differentiate this one, then the answer you get is the marginal cost. You understand? And then the marginal revenue, first of all, you convert this, you express price as a function of quantity, and then you multiply by the quantity to get the revenue. Then you differentiate that with respect to quantity. That gives you the marginal revenue. Matter of fact, if you want to find the profit maximizing level of output, just equate the marginal revenue to the marginal cost, right? Then you solve. That gives you quantity, and then take the quantity and then plug it into the price. Then you get the optimal price. Okay. Then if you want to find the maximum profits, take the optimal quantity and then plug it in the profit function to obtain the profit. So what do you observe here? We are doing what? Relative maxima as well as relative minima. First, we find the critical values, right? Critical values are what? Profit maximizing level of output. That's the critical value. The value of Q for which the pi dq equals to what? 0, right? So once you obtain that, substitute it to the profit function. That gives you the relative maxima. Understand? Now let's move on to constraint optimization. You see, unlike unconstrained optimization, here we have certain restrictions on the choices of the decision maker, right? For example, the decision maker or the economic agent is constrained by the amount of resources he or she has, right? Now, the constraint arises because of what? Because of scarcity of resources. Because of scarcity of resources. That's why we are constrained. And that's why we are making a choice. And that is why we are studying economics. If we are able to get everything that we want, there would have been no need to study economics. And there would have been no need to optimize. There would have been no need to economize. But the fact remains that the resources at your disposal are not enough. But your wants are unlimited. Your limited resources faced with unlimited wants. So that is why we have to optimize. So this is the crux of economics. So you need to make a choice between alternative. And in making the choice, you have to make sure it is the best choice that you are making. Now, take for example, I have like $10. I go to a restaurant, but I want to have variety of dishes, right? In order to maximize my happiness, but at the same time, you know, being aware that I have like $10, so I don't want to go broke. So I have to live within that $10. But at the same time, I want to get as much food as possible. I want to get a variety of dishes with my $10. So you see, I am limited here. I am constrained, or there are restrictions imposed on the choices I have to make. So because of that limited income, I may not be able to maybe choose all the dishes that I want because of the limited income. So it actually restricts me on the choices I have to make. You understand? So this is what constraint optimization is. It's because of that scarcity of resources. You don't have enough resources. You have money. Your budgets. You may want to live in a very fancy house, but your income is limited. You know, you may not be able to. You don't have the wherewithal, to buy that one. In other words, you don't have the purchasing power, so you will not be able to buy that. In fact, when we deal with private goods and public goods, you will see that you will see more of this one when we deal with private as well as public goods and the externalities, or when we deal with when we move on to asymmetric information, we look at the issue of market failures, market failing because of what? Incomplete information, right? So information is asymmetric. One side of the market has more information than the other side of the market. So information there is asymmetric. And so the market fails. So we're going to look at that one later on, okay? So, so here, when we talk about constraint optimization here, we are looking at three different basic elements here. One of these elements is what? Choosing between alternatives. So I'm going to make choices, you know, between alternatives. Like for a student, you know, you are at Campbell right now, right? Your aim is what? To maximize your GPA. You want to maximize your GPA. So you are deciding on which courses you have to take in order to maximize your GPA. But at the same time, you know, thinking about, you know, the requirements for your meeting the requirements for your major. Even though you want to maximize your GPA, you know, you're trying to look at the courses that you need to take to maximize your GPA, but you're also cognizant of the fact that you must meet the requirement for your major, right? So these are some of the restrictions that are imposed on what you have to choose, on the courses you have to choose in order to maximize your GPA, right? So maximization of your GPA there becomes what? The objective function. That is your primary goal. That is your objective, right? Your aim is to maximize your GPA, and then you have a whole range of choices. You have to choose between alternatives, different courses, right? Now, which courses am I going to choose? Which courses am I going to offer? You know, or which ones am I going to do in order to get the highest GPA? But at the same time, I have to meet the requirement for my major, something like that. Okay? So, even though you are making your choices here, but there are certain restrictions that are imposed on you as a decision maker. Okay? So, this is what we normally face under constraint optimization. So, there are basically three elements here. One, you making a choice between alternatives, and then your objective function, right? And now when we say objective function here, we are looking at what? The relationship, you know, of what you are planning to choose, what you are planning to do. Like now you say you want to maximize, you want to get the highest GPA, so that is going to be objective function. Okay, you want to minimize electricity usage, that will be objective function. But again, these are all subject to some constraint on the choices. So we'll call them the constraint, right? So for every constraint optimization, it must have an objective function as well as constraint equation. Okay? And if possible, it's also going to have identities. So this is what makes this one complex. So under unconstrained optimization, we only deal with one function, which is what? The objective function. We differentiate that one, and then we obtain the optimal values. But here, we are going to deal with two functions. We have the objective function, and then we have the constraint equation. You will see that you will see this one when we study consumer theory, utility maximization. You will see this how complex this one is when you deal with this one, because we're going to be dealing with different types of demand functions, Marshallian demand functions, Ixian or compensated demand functions, and we are also going to look at the angle curve and the income and substitution effects. So all those ones will be covered under consumer behavior. Okay, so let's move on. Now, I gave you some examples here, for you to see. The objective function is just a relationship that the economic agent seeks to optimize. What you're trying to optimize, what your goal is, what you are trying to optimize, whether you are minimizing expenditure or minimizing cost, or maybe maximizing utility or maximizing profits. So that is your objective function. And then the constraints are what? The restriction imposed on the decision maker. So the restriction imposed on decision maker are referred to as what? The constraint, right? Now, see one other example here. A consumer is concerned how much food clothing he or she should buy in order to maximize his welfare or maybe his happiness, right? So now let's look at one example here. I'm going to do this one. Now, suppose a consumer has only $50 to spend in a restaurant at lunch and is planning on choosing a collection of dishes, right? It should be off, right? A collection of what? Dishes. I think I left the OF. It should be off. Of dishes, right? All right. That gives him the most satisfaction without going broke. If there are three, I think there are so many words that I left out. If there are three, right? There are three different types of dishes, right? I did not even add the ears, right? Oh my God. A, B, and C. Each unit of A costs $PA and a unit of dish B costs $PB and that of C costs $PC. Write the objective function of the consumer. So what are you trying to optimize here? You are trying to optimize here what? Your utility. That's the first thing you have to say. Here, my aim is what? To maximize what? Utility. My happiness, right? And I am faced with what? Three dishes, right? A, B, C. You have to write them like this. A, B, and C. And then this equals to what? A, B, and C. So that is your objective function. That is done. You're done. That's the first part. It's done. Now, specify the constraint of the consumer here. Now, what is the constraint of this consumer? The consumer here wants to make choices on what type of dish he needs to buy in order to what? To maximize his happiness. So, but he's faced with three dishes, right? And he's going to spend on this one. and he has to make sure that he's living within his budget here of $50, right? So that means he's looking at how much he's going to spend on A, which is what? APA, and then plus B, PB, that is quantity times the price, plus CPC. And then this is less than or equals to what? Your income, which is equals to what? Which is equals to $50, right? So that becomes your constraint there. As easy as that. Now, which of the variables are regarded as exogenous and which are endogenous? Now, exogenous variables are determined outside the system we're analyzing. These are variables that are given, right? They are given, they are fixed. Your income, your budget is given. You know it. Likewise, you know the price of the good. So these are all what? Exogenous variables. They are not endogenous. So all the prices here are exogenous because these ones are given. Okay? So the endogenous variables here are just what? Are the amount of A, B, and C dishes consumed. Those are the endogenous variables. So you have about 3 endogenous variables here, which is A, B, and C. So those 3 variables are determined within the system we are analyzing here. We are looking at a constraint optimization problem here. So those 3 variables are endogenous. They are endogenous in the sense that they are determined within the system we are analyzing. Okay? So now to write the constraint optimization problem of this consumer, you have to have both the objective function as well as the constraint equation, right? So I've given you the solution. So that one is straightforward, right? And then you have the objective for the optimization problem here. You maximize your utility subject to that, right?